This video, I am going to show you how to use FreeCAD to design that. It's an Erector set perforated strip, and then I'm going to use my laser cutter to make it out of 1/8" plywood. So it's really fun to be able to make your own construction set pieces. You can make whatever length you need, whatever shape, and customize it however you want. Here's an example of, I realize the video here is really choppy, but these are mostly standard pieces that I've put together with a custom motor mount here for a very cheap stepper motor on Amazon, and it's a linear axis. It just moves back and forth, and I used 3 of these to make this Delta robot. And this Delta robot is mostly standard construction set pieces. Here's the linear axis here, 1 of 3, and yeah, so fun stuff. And I could use a caliper to measure this, you know, but I'm not going to, because all the Meccano drawings seem to be on the internet, and I just searched for Meccano technical drawing, all the way back here, and we'll just get the 2" perforated strip. And this tells us everything we need to know here. So just drag that down here and switch over to FreeCAD. This is FreeCAD 0.19. I originally did this with .18, but it has a bug that prevents DXF export, so use 19, I recommend. Okay, so I'm going to start a new file. I'm going to create new. I'm going to save this as construction set. Yes, overwrite that. And the first thing I do is set this to gesture, because I don't know how to navigate in this program otherwise. But the next thing I do is create a spreadsheet in which I will define my dimensions. I find that this is the best way to make things parametrically defined is to use a spreadsheet here. So this is what I start with. I'm going to rename this to dims. It's my cool name for dimensions, and I'm just going to start entering the dimensions that I know. So we're going to go to the drawing, and okay, I'm going to start with the width here. I will call it strip width, and that is 0.5 inches. So with a spreadsheet, you have to tell FreeCAD, you can enter values, but you have to tell FreeCAD what that value is called, and putting it in the first column isn't enough to do that. This is just for my visual labeling purposes, so I'm going to copy this, do properties here, and you have to set the alias. This is what tells FreeCAD what you want to call this value, and it will turn yellow when it has an alias assigned to it. So going back to the drawing, let's do the whole spacing or whole pitch. I'm going to call it pitch. 0.5 inches. Have to tell FreeCAD what it's called. Alias. Okay. What else? The whole diameter. So there's an upper and lower range here. We'll aim for the middle, which is .169 inches. Whole diameter, .169 inches. Alias. And the end cap radius here is 0.25 inches. So call this end radius 0.25 inches. And I'm also going to define the number of holes, because I want to make this also adjustable. And the length of the strip will make it dependent on this value. And the number of holes will also automatically change based on this value. Okay, I think that is it. I'm going to save this. Okay, I'm going to go into the drawing window here and do all my work in Part Design Workbench. This is a workbench selector. There's lots of cool stuff you can do. 90% of it I am unfamiliar with. And so I'm going to create a body. A body in FreeCAD is a single solid. It's a single piece, a single continuous piece. So we're going to create a body, and let's give this body a name. We'll call this, wow, how do you, perforated strip? Is that what it calls? Is that what it's called? Perforated strip. Perforated. That looks all right. So a body is composed of sketches. We'll create a sketch. A sketch is a two-dimensional drawing. I always put my sketches on the XY plane. It makes everything simpler. And then, yeah, I'll just go with that. So XY plane means that you're looking down from the top. And you can see here it says top. So I've done this a few times, and I had a few false starts. There's probably like 10 different ways you could draw what we're trying to draw, but I'm going to draw it this way. These are the two toolbars that I use in Sketcher, which is the mode here that you make sketches in. And this is the toolbar for selecting what kind of shape you want to draw, and this is the toolbar for applying constraints to the geometry. FreeCAD is parametric constraints-based modeling, 3D modeling program, and you'll see how it works. So I'm going to start by drawing the arc at the end. So this will allow me to draw an arc. I'm just going to rough it in, and that's what I do with most of the things here, because then you apply constraints to tell it how you want it to be. So I'm going to put this first end. So the first hole, the hole at the end of the strip, is going to be centered on this point here. So I'm going to put that at the origin of this sketch and use this coincident constraint. So it put the origin of the circle to which this arc belongs centered at the origin. So the thing we know for sure about this arc is it has a radius. We know that from the dimensions from the drawing. It has a radius of, who cares, because it's in our spreadsheet. We don't need to know it. So I'm going to constrain the radius of that, and I can enter a literal numeric value here, but better, I can hit equals and type in dims dot end radius and select that, and then when if I change that value in my spreadsheet, it will change here. So we can just leave this like this for now. So I can also specify the same radius for this, or I can select these two and apply an equality constraint, which will make them the same size. So there are a bunch of different ways to do these things. The other thing I want to do is make sure that the center of this is horizontally aligned with the center of that. And I could either select these two and apply a horizontal constraint, or I can just put, since this is at the origin and on the x-axis, I can take this point and put this point, use fix point to object, and put that on the x-axis. So now these points are always going to be aligned. What we'll do next is draw the top and the bottom of the shape. Again, I'm just going to, well, we can actually put it right on that point. So when I hover over that point, it turns a different color, and that circle with the X around it shows up. And that's the symbol for a coincident constraint. That means the 2 points are on exactly the same spot. So that's telling me that if I click here, it's going to automatically apply a coincident constraint, which is what I want, because I want this line to be connected there, so I'll do that. And so you can see there's the coincident constraint here, which I want, but there's also that horizontal line, which is telling me it's going to automatically apply a horizontal constraint, which is what I want, so I'll just click it. And you could always go back and delete that constraint if it applies something that you don't want. So I'll do the same down here. So that's good. Right. So the next thing I'm going to do is set the width of this. So I'll select these 2 points and set the vertical distance. Equals dims.strip width. Okay. All right. Okay. So the last thing I want to do here is, I don't know why it says 2 degrees of freedom. I think there's only one. This is the only degree, as I can make it longer and shorter. Everything else is constrained. The distance between here and here is constrained by the width. The radius here is defined there. The radius here is defined through equality with that one. So I'll set the horizontal distance here. So each of these is going to be the end, the last hole at the end. So we can set this to equals dims.numHoles minus 1 times dims.hole pitch. Yes, yes, okay. And we can see that that matches what's in the drawing. So 1.5 inches, and we can see here that's 1.5 inches from center to center. And there's still 1 degree of freedom. Why does this dislike me so much? Anyway, I'm not going to fight with that now. I figured out why the sketch wasn't fully constrained here. I did realize that there's no constraint making these 2 lines of equal length. So if I apply an equality constraint there, you can see it says fully constrained sketch, and that's really what you always want to see. And that means that there's no variability in your geometry. It's completely locked down. I'll close this. So we've made a 2-dimensional sketch that defines the outline of this piece. Now what I need to do is give this a 3rd dimension. So I can left click and drag around, and we're navigating in 3-dimensional space. It makes it a little easier if I can hit spacebar and toggle visibility of things. So I can make the origin disappear, the sketch. So hitting spacebar toggles visibility of things over here. So yeah, and the number is 1, 2, 3, 4, 5, 6, 7, 6. 6 sides. Switch between these normal views. So 2 switches to top. So we can see this is how we drew it. And then I can like pan down. You can see that's just a 2-dimensional drawing. We need to give it some thickness. One thing I didn't define here is how thick the material is, of the plywood. So I'm using 1/8 inch plywood. So I'll set that here. Okay. So to give this a 3rd dimension, I select the sketch and then use this pad operation. and padding just makes it thick. I don't know. So I will hit equals here. You could also click on this to get to the formula editor, but I'll do dims, material thickness, and yeah. So now we have an 1/8 inch thick solid. All right, I'm going to turn off that origin. Now it's time to add a hole. So to do that, I will create a new sketch. So this pad operation is based on this sketch. I drew a two-dimensional thing and then I added thickness to it. So that's one operation. The next operation is going to be one that takes material away. So, and that's going to be this pocket operation. A pocket is like a hole in a thing. So I'm going to create another sketch, create sketch. I'm going to put it on the XY plane again because that's what I always do. And I don't want to see the solid body. I want to see the underlying 2D sketch. So I'm going to go back to model. I'm going to hit spacebar to hide that, but I want to see the sketch that I use, so I'm going to make that visible. And I'm not going to use it, I just want to see it. It just brings me peace of mind. So I'm going to go back to my sketch here and make a hole. Alright, and I'm going to put that hole, well, I'm going to make that hole the correct size. Equals dims, that hole diameter. And I'm going to put that hole right at the origin. That's it. That's fully constrained. And I'm going to use a fancy FreeCAD feature to create the rest of the holes automatically. So I'll close this and I'll show the solid again. And now I'm going to create a pocket operation. And I want to cut through the entire solid, so I'm going to say through all. And I need to do reversed. I'm not going to explain it, but that's, yeah. If I can go back in here, I mean, we can look at the drawings on the bottom of this solid, and I think pocket operations by default go in some direction. I don't know. Usually I just keep clicking reversed until it does what I want it to do. Right, through all. So it creates a hole. That's our first hole. And so this is like a list of operations. This is our body, a single solid. We have a pad operation that creates a three-dimensional form. We have a pocket operation that takes some material away. And this pocket doesn't need to go through the whole material. If we only wanted to go halfway through the material, we could do some math here. We could do equals dims dot material thickness divided by 2. And it's going to put that on the bottom. But you can see it only goes halfway through there. But we want it to go all the way through. So easiest thing is to just do through all. Right, so here's that fancy operation I promised. I'm going to select this pocket, and I don't know why my toolbars are all crazy. Right, just go up there. So there's this right here. This is create a linear pattern. So you can repeat an operation. You can mirror an operation. So I could mirror this whole based on some reference point to a different side, but you can create a linear pattern. So that's what I'm going to do. And direction is based on the horizontal sketch axis. And I want to say the number of holes, and you have to specify the distance over which you want this many occurrences to be spaced. So you can't specify the spacing between them, you specify the start point and the end point distance. The distance between the start and the end. So that's going to be this dims num holes minus 1 minus 1 times dims dot hole pitch. Right, and so it automatically gives us the holes we want. And that looks right-ish. And what's really cool is that I can now change this and it automatically lengthens the strip and also creates the correct number of holes. So there's our piece. I'm going to put this back to 4 and let's look at this. Man, this FreeCAD 19 does some different things. So, right. We're looking at the, let's look at the top. Sure, let's look at the top. So, the next step, have I saved this? No, of course I haven't saved it. I'm going to save it. The next step is to save this shape. I want to use this to cut this on a laser cutter, so I just need a two-dimensional SVG. I just need the top view. I just want to export that. And to do that, I need to select, well, first look at it from the top. Select the thing that I want to export. Maybe I don't do that yet. Go to the draft workbench. So go to the draft workbench. Okay. And make sure the thing I want to export or project into 2 dimensions is selected. Go to Modification, Shape 2D View. Okay, so that just created a 2-dimensional view of the shape from the perspective that I'm looking at it. So I can make the 3-dimensional object invisible. Now you can see I just have a 2-dimensional projection of that object. So I can export this. Export as I'll call it that, and I want to export it as a DXF. The SVG, the circles don't export right with SVGs, but it seems to work with DXF. I'll save that and take a look at it in Inkscape, which FreeCAD is an open source program, and Inkscape is an open source vector drawing program. It's really awesome. Before I learned FreeCAD, I used Inkscape for everything, for all of my laser projects. Okay. And that just moved it to a different desktop. All right. So it's down there in the corner. I'm going to do document properties, resize page to contents, millimeters 1, equal margin on all sides. All right. Whoop, I get confused between the 2 programs. So I will take this and format it how I need to for my laser, and then show you what it looks like cutting it. All right. Here it is in the laser program. I've colored the holes red and told the laser to cut them first. So let's do it. Press the play button. bolted it onto that Meccano piece, you can see that it fits. I didn't compensate for the kerf of the laser, so the amount of material that the laser takes away. So the fit's not perfect, but that's another thing I could include in the FreeCAD spreadsheet and compensate for automatically.